Boundary layer. As previously discussed, the boundary layer is a thin layer next to the surface of an object in which the velocity of the air particles increases from 0, the no-slip boundary condition, to the full value of the free-flowing air. On a wing, the airflow within the boundary layer initially starts laminar from the leading edge. Laminar means that every small parcel of air has a definite velocity, and the velocity varies smoothly from place to place. As the air moves back on top of the wing, at some point the boundary layer will become turbulent. Turbulent means the velocity of every parcel of air fluctuates rapidly at any given point, and at any given time, even between nearby points. The change from laminar to turbulent is called the boundary layer transition. Also, at some point, before or after the transition to turbulence, the airflow will become separated. Separation means the air doesn't follow the contour of the wing. The wing can't force the air into the optimal flow pattern, so not as much low pressure is produced. Whatever low pressure is produced is not attached to the wing surface. Aircraft designers try to keep this region of separation rather small and near the trailing edge. In order to make a wing develop a lot of lift without stalling, it helps to minimize the amount of separation.